physics is the science that aims to understand the fundamental nature of reality, from the smallest particles to the largest structures in the cosmos. However, in recent years, physics has faced a series of challenges and disappointments that have cast doubt on its ability to achieve this ambitious goal. Some physicists have even declared that physics is in a state of crisis and that a radical change of perspective is needed to overcome it. But what is the nature of this crisis, and what are the possible solutions? One aspect of the crisis in physics is technical and concerns the limitations and inconsistencies of the current theoretical framework, known as the Standard Model of particle physics. The Standard Model describes the elementary particles and their interactions and has been remarkably successful in explaining and predicting a vast range of phenomena. However, the Standard Model is not complete and leaves many questions unanswered, such as: what is the origin of mass, and why do particles have different masses? What is the nature of dark matter and dark energy, which make up most of the universe but are invisible to our detectors? What is the origin of the matter-antimatter asymmetry, which explains why the universe is made of matter and not antimatter or nothing at all? How can gravity be reconciled with quantum mechanics, the two pillars of modern physics that seem incompatible at the most fundamental level? To address these questions, physicists have proposed various extensions and modifications of the Standard Model, such as supersymmetry, extra dimensions, string theory, and quantum gravity. However, these theories have not been confirmed by experimental evidence, and in some cases, they are so mathematically complex and abstract that they are beyond the reach of current or foreseeable technology. Moreover, some of these theories introduce new problems, such as the fine-tuning problem, which refers to the need to adjust the parameters of the theory to extremely precise values in order to match the observations, without a clear justification. Another aspect of the crisis in physics is philosophical and concerns the interpretation and meaning of the physical theories and concepts. This is especially relevant for quantum mechanics, the theory that describes the behavior of matter and energy at the smallest scales. Quantum mechanics is notoriously counterintuitive and paradoxical and challenges our common-sense notions of reality, causality, and locality. For example, quantum mechanics implies that particles can exist in superpositions of two or more states until an observation collapses them into one definite state. Particles can be entangled, meaning that their properties are correlated even when they are separated by large distances, and that a measurement on one particle instantaneously affects the other. Particles can tunnel through barriers that would be impossible to cross classically, such as the nucleus of an atom. Particles can behave as waves, and waves can behave as particles, depending on the experimental setup. These phenomena have led to various interpretations of quantum mechanics, such as the Copenhagen interpretation, the many-worlds interpretation, the pilot wave interpretation, and the relational interpretation. However, these interpretations are not empirically distinguishable, and they often involve metaphysical assumptions and implications that are controversial and debatable. For example, some interpretations imply that reality is probabilistic, indeterministic, or relative, while others imply that reality is deterministic, hidden, or multiple. Some interpretations imply that the observer plays a crucial role in the creation of reality, while others imply that the observer is irrelevant or illusory. Some interpretations imply that quantum mechanics is complete and universal, while others imply that quantum mechanics is incomplete or emergent. The lack of consensus and clarity on the interpretation and meaning of quantum mechanics has led to confusion and frustration among physicists and philosophers, and has raised doubts about the validity and relevance of physics as a science. Some physicists have argued that the interpretation of quantum mechanics is irrelevant and that physics should only focus on the mathematical formalism and the empirical predictions. However, this attitude ignores the fact that physics is not only a technical enterprise, but also a conceptual and cultural one, and that physics should not only describe reality, but also explain and understand it. How can physics overcome the crisis and regain its confidence and vitality? There is no simple or definitive answer to this question, but some possible directions and suggestions are: seek new experimental data and discoveries that can test and falsify the existing theories and inspire and guide the development of new ones. This requires investing in large-scale facilities and projects, such as particle colliders, telescopes, and gravitational wave detectors, as well as exploring novel and unconventional phenomena, such as quantum information, quantum metrology, and quantum biology. Seek new theoretical principles and frameworks that can unify and simplify the existing theories and resolve the outstanding puzzles and paradoxes. This requires being open-minded and creative and exploring alternative and unconventional ideas, such as non-commutative geometry, loop quantum gravity, causal sets, and quantum Bayesianism. Seek new philosophical insights and perspectives that can clarify and enrich the interpretation and meaning of the physical theories and concepts. This requires being critical and reflective and engaging in interdisciplinary dialogue and collaboration with other fields such as philosophy, logic, mathematics, and computer science. Physics is a fascinating and rewarding science, but also a challenging and demanding one. The crisis in physics is not a sign of failure or decline, but rather a sign of growth and progress. The crisis in physics is an opportunity to rethink and redefine what physics is and what physics can do. The crisis in physics is a call for action and innovation. The crisis in physics is a chance to discover and create new physics.